let's get started. Here's the quick agenda. So we're going to be running a bit late, but let's just do some intros. Mainly want to introduce Rabimba, who has joined us today. He is a Google developer expert, and Rabimba, why don't you just introduce yourself?
Yeah. Hi, everyone. Thanks a lot for joining. I know we have been trying to do this for now. It's the third day. And thanks at least for sticking with us till the end. My apologies for having to postpone it day after day. So I'm a grad student. I'm doing my PhD, hoping to finish soon. I'm a Google developer expert in web and recently also became in machine learning. I work in the intersection of security and right now also a little bit on large language models and AI in general. So that's me, and thanks, Anne, for having me today.
Thank you for joining us, and thank you everyone for joining us today. So before we get started, just a bit of an intro about this platform that we are on. It's called Bevy, and on the right-hand side, you will find all the different tools that you can use to interact. Of course, you can use the buttons on the bottom of your screen to unmute and ask anything, but you can also use the chat panel to um, write questions, and I'll be on the lookout for those, and uh, we can answer your questions through that as well. Um, all right, I guess that's all from my side, and over to you, Rabimba.
So hi everyone. Since it's going to be more like a workshop, I wanted to make it a little bit informal and wanted to kind of know all of you. And I intentionally today, so I have a slide, but I am not going to go through that. And instead, we are going to make it more interactive because there's less number of people, and I want you all to kind of participate. So it will be wonderful if you some of you can like just a little bit introduce yourself and kind of like an expectation what you want to get out of this workshop, so we will have a kind of like more productive session today.
Um, Hi, I'm Tim Dove. Can you hear me?
Yes, I can.
Okay. I'm from Cornelius, North Carolina, a little north of Charlotte. I lived a long time in Raleigh as a software developer. The last, say, 6 months, I've gotten back to software developing and I've really studied artificial intelligence. I went to a meetup the other night where a guy talked about LangChain just a little bit, and I went home and downloaded it and installed it and looked into it, and it's quite amazing. And I just kind of wanted to see. I'm just trying to learn a little more, get my feet wet in it, and kind of understand what it is, what it does, and how it can help us move forward with LLMs and such.
Awesome. And anybody else want to go?
Hi, my name is Hamza from Ghana. I am a software developer, but I have have grown a lot of interest in large language models, and I'm looking at using large language models to work on some projects. And I thought that this workshop would be uh, very good for me. So I'm hoping to learn a whole lot on how to apply LangChain to some of the projects that I'm taking off. Yeah, that's
Awesome,
it.
thanks for sharing.
Hey, I can go next. Hi all. I'm Sashiran. So I recently got to work with a little bit of LangChain because there was a hackathon in our company, which was hosted by Databricks, and they got us exposed to the Dolly model, and we took some internal data and we got to play around with it. So I was really impressed, by what we could accomplish just with like a one day of a hackathon, and what we could kind of start seeing as results. It was quite exciting. So that kind of got me interested into this. So yeah, thanks so much for hosting this, Raviman and Anand Patel. Thank you so much for putting together this event.
Thank
Thanks
you
a
so
lot for
much.
sharing.
Hi, I can go next. Hello everyone. My name is Heather. Uh, I just joined the meeting, so I'm a little bit familiar with large language models as I'm working on projects currently. I'm a student in United States and looking forward to this meeting.
Awesome.
Okay. Hi, myself Ujjwala here. My company is going into the AI and ML space right now, and I heard about the LangChain on another AI meetup, and I just want to learn more about it. That's why I'm here.
Awesome. Uh, Thanks a lot. I think we went with, yeah, I think we almost went with everybody, right?
Yep, that's probably everyone.
Okay. So let's start today. So I initially thought I won't go with the slide, but let's start with little bit of a different talk I have on this, and then we are going to go into why LangChain or why even LLMs. What is it supposed to be? So let me share my screen. Okay, so you all can see my screen. Let me open this up as a slide.
Sorry to interrupt you. I don't know if it's only me. I hear like some kind of static noise. I don't know if it's my issue or.
Actually, I hear it as well.
Yeah, I hear it too. Let's see. Is it gone
Oh, it's
now?
gone now. Yeah, it's gone. Yeah.
I
Thank
think
you.
it was probably from one of the attendees. I unmuted there. I
Oh, okay.
muted them.
Okay. Thank you so much.
Okay, so this is a talk I gave a couple of months ago in Charlotte, and I just wanted to start with a little bit of talk so that you have a context of what can we do using LangChain, and then we'll go deep dive into LangChain. How I envisioned this workshop to be is that uh, first, after talking a little bit about what we can do with LangChain, we will go with a back and forth of actually going through LangChain documents of what are the features available, what are the myriad things you can do with it, but also follow along in a Google Colab, which I'll share later, where you can actually run those codes, actually see the outputs, change it, and play with it. For today's workshop, you so okay. First, let us start. Then we'll talk about what you will need to follow along. Um, so shared a slide. Are you able to see it full screen?
I think it's should be full screen.
Okay, because for me it shows like half screen, but yeah, if you can see it full screen, then that's awesome. Uh, so little bit about me. Hi, I'm Rabimba. That's my friend. I'm a Google developer expert in web technology. When this slide was made, I was just in web. Right now, I'm in web and machine learning. I'm also a cloud champion innovator in AI and ML. My full-time job is a student. I'm still doing my PhD, and yeah, that's what I am. So how it all started after this huge kind of boom with large language models and everything, I was thinking of that. Since I'm going around talking about it, since I'm playing with it, and not only this, I'm playing with a lot of things, I thought, okay, time to kind of revamp my website, my personal website. And then I thought that, can't I integrate LLM to do something? And while I tried to do it, I was met with a little bit of surprise where I realized The large language model, which I wanted to know about me, started answering questions in a detail which I did not envision. For example, if you see the slide, you will see that I called large language model. For this one specifically, I called Google's Palm, and I already had trained it on my CV and my website data. And when you ask that, does Rabimba travel a lot, which is not part of my CV, I can pretty much assure you that, and also that's not part of my website blog posts, rather. Uh, the LLM was able to answer something like, yes, Rainbow Karanjai travels a lot for his talks, which should not be part of something it should be able to infer. That got me interested that what's going on. So what we are going to cover today is what is a large language model. The other parts are specifically for that talk, but we will cover that because we are going to talk about large language models and also LangChain. And the technology I want to show you today is large language model or the model agnostic. So you should be able to run it regardless if it is a Google Palm or it's a OpenAI GPT interface, or if it is something open source like Facebook's Llama, Bloom, or something from Cohere or something else. So with that, how many of you have a little bit of idea about what is a LLM? In very short, in a very dumb way, if we think about a large language model, what does it actually do? Anybody wants to take a guess?
Can I go?
Yeah.
Yeah. So basically, large language models is like a model, a transform model which is able to identify relationship uh, between each tokens or like word we say, uh, which uh, which previously it came from uh, recurrent neural networks and then LSTM and now large language models.
Awesome. So thanks a lot for that. So if we actually kind of even more dumb it down, what large language models do is predict the next word, or what the normal nomenclature is predict the next token. But in a very dumb way, if we dumb it down, it actually predicts the next word. But that has been around. Like, it's just not autocomplete. So why it is so good? So it is able to predict the next word based on the previous what it was trained on, of course, but also how your sentence is looking like based on the context, on how that similar context might have looked like. So that's why it's able to guess it better, but essentially it still is guessing the next output. So something like this, when we have something like roses are red, it automatically tries to see, takes the pattern, and it tries to say, okay, then violets are blue, sugar is sweet, something similar. So if we think of it in the coding perspective, if we have something like for variable I is equal to 0, it will try to do this, that it will try to write I less than 10, I plus plus, and go ahead. Now, the interesting part is why I less than 10 or like I less than 10, I plus plus. It could be anything else, right? Anybody has any idea why it might produce something like that? So in short, what it does is that the code it was trained on, the plethora of code it has learned from, a lot of times it has seen these kind of patterns getting repeated. Not only this kind, very specifically might be even this exact code getting repeated. So LLMs are prone to, as we know, LLMs are prone to hallucination. But one part of this is LLMs can actually memorize things as well. That's why initially people had those problems where ChatGPT was spinning out varied API keys because it was trained on those. Now, what it essentially does is take a probability of that what can come after that, and that's why this it becomes. If we'd have written a very different kind of code a lot, then that would have come here. So that's essentially LLM. Now, let's look at some of the classic natural language problems. And if we want to do these using LLMs, how would we do it? So some of the natural language problems we know are kind of like entity extraction, classification, summarization, sentiment analysis, translation, and so on and so forth. Now, one of the huge use cases in LLM is synthesizing or generating text. So that falls into like the generative AI part. So, for example, if I want to explain this joke, I used to be addicted to soap, but I'm clean now. This joke is pun on the word clean, right? It has two meanings. Now, imagine this: if this is a joke, but if you try to autocomplete it on a training data set that I used to be addicted and then don't do anything, what might be, or like do something like a completion that I used to be addicted but I'm clean now. Or if you ask it after this that, okay, what is like I'm clean now, what was I used to be addicted to? Unless you have a context with this, very likely your model probably will give you very different answer, because soap is not something normally people gets addicted to, and it's not something the language model has learned from its association. So these are funny because it is unexpected, and it's also unexpected for the model. So when you ask it something like, give me 5 neat ideas for science fair project, always keep in mind that these ideas which are being generated, they are part of some data set. Somebody has something similar which it can associate with an idea, hence you have it. So we always need to remember the generation or the generated text, whatever we have output from those, are going to be kind of like things it has learned from dataset. So be very careful about like what is coming out of that. Now, why this? Because these large language models let us prototype very fast. Any of you have played with ChatGPT or any of these just for coding before?
Yes.
And you might have noticed that when you use it for coding or at least building anything, it's much faster than Googling out, trying to see boilerplate code, trying to use that. You just type it, it takes away a lot of intricacies, it just gives you a boilerplate code, which in an ideal world should just work, right? So in an ideal world, LLMs lets us prototype very fast. Now I am going to stop sharing because this will go to very specific to MakerSuit and start sharing something else. So to follow along, we are gonna use LangChain, but LangChain alone is just a orchestration tool. Any of you have played with LLMs apart from ChatGPT before?
No, I haven't.
Oh, okay, awesome. What?
No, I said I haven't used anything else.
Okay,
Personally.
awesome.
Yeah.
Awesome.
So
Yeah, go ahead.
sorry. Yeah. So I have built my own LLM. So I have fine tuned it on a particular data set.
Okay,
Like,
so what was the foundation model you started with?
so I started with the recent model, which uh, uh, which is Microsoft 5 1.5 billion model, and I'm
The
training.
5.1?
Yeah, sorry.
The 5.1?
Yeah, 5 1.5. The 5.1 was an older version, and 1.5 was just released 2023.
Yeah. So whenever you have played with any of these,
Uh,
even when you trained it on like you trained it and you can play with it, you probably wrote the code in Python and you're running probably a notebook or something somewhere and communicating with it, right?
yeah.
Now if you wanted to use more like an API, or you want to have other aspects of it, for example, you want to use that more specific model for ingesting a part of PDF, ingesting a part of web page, and start answering data on that. In that case, you need to do some other orchestration on that, right?
Yeah, correct. Like I mean, LangChain is required for that, or some other tool.
Yes. So that's the like exact point for the existence of LangChain, Llama Index, or all these. These are all orchestration tools. These are not LLMs. These are not also LLM specific. They all have adapters which can talk with other LLMs. For our workshop today, we are probably mostly gonna like communicate with a couple of them to show that how you can communicate with them. But there are a lot of other agents which you can use to kind of communicate with them and do different stuff on that. With that, I'm gonna share a different screen.
Sarah, you're supposed to be sharing. Oh, there it is. Good.
Okay.
When you said a different screen, I thought that you might have not known your screen share wasn't on.
Oh no, yeah. I am sharing the right one, right?
Yep. Yeah. Believe it or not, it happens a lot.
Yeah. No, I know. I have done it as well. Okay. So with that, we are actually gonna go a little bit back and forth because I want you to actually look at LangChain's proper documentation, go through like what exactly is there, and go to the like collab so that we can like map that what's available there. So with that, we with that, we'll use LangChain to mostly kind of see what we can do. So all these comes from like the LangChain docs. So if I press the LangChain docs button and share this tab instead, which is, I think they did it. Give me a second. I can just Google LangChain docs. So LangChain is essentially a framework. We can use it to kind of connect with each of these LLMs. A lot of these LLMs have their own APIs and we can connect with them. For our purposes of this tutorial, we are gonna go for specifically Google Spam, a little bit, and mostly OpenAI because that's what most people are conversant with. But I also want you to kind of have a knowledge about how you can do that for like thousands of open source models that are available in Hugging Face. So we will go through also that part that if you want to have something, if you have a model in Hugging Face, for example, Bloom or Llama or any of those, or any of the like modified models which are available there, if you want to interact with them, how to do that. It's very easy, it's very small amount of change, and we will go through that. Before that, this is exactly the two things we are going to go for. So when we say components, these are different tools, different small snippets of codes which the LangChain community has built, which allows you to do a lot of very nifty stuff, which otherwise you would have to code for yourself. Some of those use cases include ingesting a PDF, ingesting a web page, ingesting almost any kind of data available. For example, right now there are adapters available which let us connect to Google Drive to ingest a whole drive of data and work on top of that. There are adapters available which also lets us kind of like create a PowerPoint presentation or any kind of code or any kind of like summary based on those. So those are components. These components are hugely powerful because they kind of let us mix and match this and build our own solutions, whatever we want to. Then there are use cases. Use cases can be thought as like very specific implementation of those components as a chain, which does a very specific purpose. So I will share a like collab later, which I built for that talk, which does exactly one thing, which is it ingests my website, it ingests my CV, and it comes up with an API. So that one doesn't, but that one gives you like a API endpoint where you can just type a question about me, any question about me, and it should be able to answer. Now there are two parts of it. One is that where we just ingest the data and it can answer on that. But is that something new? That is essentially what? That's essentially searching the document. Then we can do something called so there are two things we can do. We can do a retrieval augmented search where we can actually go through the concepts and it can search. It can do a little bit more than search. It can try to learn the concepts, like trying to learn the associations and do something on that. Or we can ask, or we can try to fine tune it based on very specific one-shot ways to fine tune, which we'll show, where it will be able to build more associations based on those data. This was very similar to when I tried to ask it that, okay, does Rabimba travel? And it was able to answer, which was not part of the search query. It should not be able to answer that just from looking at the documents. So these can be use cases, and there are a lot of use cases which are already kind of like implemented part of it. Next, when we go to components, we have very different things. We have schemas, models, prompts, index, memory, chain, and agents. We will not cover all of them today. We will cover models, which are essentially the large language models, which we can connect to using LangChain. We will cover prompts because, as we all know, prompts is exactly our input, and that's how we interact with these models. There are more intricacies than these prompts than just asking for a question answer. Some of the models, for example, Facebook's Llama family of models, can also have something called instruction prompt, which kind of builds a theme based on how it can answer. Google's Palm family has an option where you can ask it to very specifically answer as a persona, very similar to ChatGPT's persona. But you can also ask it very specifically to build things, for example, use tools called calculators and stuff, which normally the LLMs struggle with, but it can use external input to alleviate some of those concerns. So these are the extra things which we can pass as prompts. Then there are memories and indexes. We will go very shortly on them. Before we go there, anybody has any idea what this memory mean, or what does memory mean in the context of LLMs?
Is that the context of the conversation?
Yes. Now, if you have been like me, who when like ChatGPT or any of these LLMs were released, thought these as a new toy and kept on playing with it, just whatever they want. Have you ever noticed when you, not for really cache, but imagine this is context. Context means memory. For example, when I'm talking with you, do I forget what I talked to you maybe a long time ago? Or if you give me a long document to read and I forget about that? So the memory associates it with the context. So there's a limit to how long this context can be stored and how long it can be, like how long these LLMs can relate to that. If you have played with the GPT-4 part of not the normal one, when it was integrated with Bing, and a lot of people played with it, and there were a lot of interesting outputs. One of those outputs was that if you keep on talking with it, you will see it will start forgetting what you have started to talk with. And then there was this huge kind of like funny, not only meme, but conversation that it becomes emotional, that when you start asking it that, okay, what did we talk about? And it wasn't able to answer, things like that. Eventually that got elevated, or rather railguarded, when it was defined that we only can do like 20 conversations and things like that. But if you are building an application and you want to work with imagine in your company with all the documentation you have. Imagine you are building a interface where any new onboardee in your company can just type a question and they get answer based on all the help docs you have available, based all the Confluence docs you have available, based on all the existing bug reports available. To do that, to do a you have to have some kind of vector database where you can store it. But that's not all. Imagine this new onboardee keep on asking questions and questions, and it should, your question answer system should have a memory where it can have like a whole context of where the questions are going. That's why the memory is important, and we will know how we can actually use third-party libraries and the adapters from LangChain to do that. Chains are very specific implementation as well as agents. We will use very small part of that, but I will go to what they do. Do we have any questions till now?
So I have a question. Well, it's more of a doubt, but I want to confirm it. What I heard about these LLMs is that at the core, they just are these predictors that predict the next token given some context. And all of these chat models, I think that what they are basically doing is in a particular chat session, it always collects the entire chat history and feeds it back to the model. And then the model reads the whole thing and plops out the next tokens. Is that accurate, or is there something more to their architecture?
No. So in overall, in very like broad term, that is accurate. How it is done exactly is more little bit more intricate, because so essentially imagine what it's doing. If I want to manually do it, what I will do is that I just type a question in ChatGPT. I got an answer. Next time, I have a like Excel sheet open where I just have two columns that me ChatGPT. I just copy paste those. Next time, I give it to a new ChatGPT session with this context, answer the next question. So imagine if we want to do it manually, that is what essentially what's happening, but through API. Now that's very inefficient. Just to how you keep that memory, right? Instead of that, you can utilize other things, like we can post it in a database, we can tokenize it, and we can do a lot of other nifty things so that to keep that memory. But yeah, overall, in a very high level, what you said is correct. That's why even though we have LangChain, even though we have all these, actually making something production level even now is not really very like feasible. That's why even all the other like applications you see enforce a limit of how long you can how long you are, if you are chatting with it, how long the memory is there.
Yeah, makes sense. Thanks.
Okay. So one thing I wanted to make this as a discussion. One thing that should come out of An's question is that if we are doing this, then so does our model even learn anything? Like, is it learning anything from our chats? Is it learning anything from our conversations? What do you think?
My guess is it depends on that particular, like, the company that's offering an interface to interact with that model. They can retrain it with the data you fed it, because it all goes through their APIs.
Okay. Yeah. In a long plan, that is true. But if you just imagine as a developer perspective, no, whenever we are talking with any LLMs, whenever we are chatting with any LLMs, those data might be stored for later training, later fine tuning. None of these are right now online, like they are not learning from anything from us. All these weights, all these models are frozen, and they cannot be like learned on the go, cannot be tuned on the go. Why this is important for us? When we build any architecture, anything using LangChain or anything, we must keep it in mind that we cannot have a model which is learning from the user experience. We can keep the history, we can keep everything, we can use those data to train it later and deploy a newer model with that training. But this cannot be part of the, like, it cannot learn automatically. So that's something we should keep in mind.
So Ravimba, if I can ask a question.
Yeah.
The LangChain model used by ChatGPT or Llama to everything, would all, is that proprietary and is that different from each other?
Yes, I mean, they don't use LangChain at all. They have, everybody has their own like system of orchestrating and all of these. LangChain or Llama Index, all these came into existence because the open source community or the community in general didn't have a good way or didn't have a good infrastructure to talk with these APIs, right? So when OpenAI released this API, when that became part of Azure, and Azure has its own version of API, when Google released Palm using either Mikasuit or Vertex, each of those are a little bit different on how you work with it and how you interact with them. And also it eventually became very clear that everybody wanted to use it for their own data, own PDF, own kind of thing. So it became an opportunity to have a tool or have a kind of like translation layer which helps you do that. So LangChain is exactly that. LangChain is, imagine LangChain is just your helper, which helps you talk with these different models, have a single waypoint which you only have to learn one thing. Not each of these APIs, not write code for them, each of them separately, and it takes care a lot of these like toolings. Just think of it that way.
So can I say, as an analogy, LangChain is something like a REST framework, which allows you to interact with API calls?
Even little bit below that.
Okay.
LangChain is something which allows you to build REST frameworks with very small amount of code. So imagine LangChain is Bootstrap for CSS.
Okay, like Bootstrap for CSS.
Yeah, LangChain is a framework. So it's literally a tooling framework which makes a lot of things easier for you.
Makes sense. Okay. Thank you.
So kind of it like abstracts the interface to each model, and that you gives you a unified interface to talk to tons of models. And when a new model comes in, they can create an adapter for it, and you can then just use LangChain to call that model and play with it.
Yeah, that's perfectly correct. So when we go into the demo, you will see then when when we are interacting with the models, there is exactly like one line of code, and that line does not change based on like what model we are using. So we are gonna interact with 2 or 3 of them. So we are generally just calling that. So imagine you are doing that using LangChain or Llama Index, and I'm pretty sure there will be more frameworks like this. So you just learn how they do it, and all the intricacies are already implemented by the community inside those tools. So all those are taken care of. When the API endpoint changes or something else changes, that is being worked on by the community, like the maintainer of these projects, so that you don't have to. You have to just maintain that, okay, this is how I build the code, and it should technically just work. So that's the actually, philosophy behind that. So let's start looking a little bit into the schema. So schema are like what the data type is, how we work with that. So we'll start with very basic in text. So when we start with text, it's literally like most of these models where we just pass a text and get a text in, text out. So remember when I said there are 3 kind of like input prompts. Those prompts are these. Not all of these are supported by all of the models, but most of these, for example, what I said, the Facebook's Llama model has the instruction set, which essentially is the system chat message. So this essentially works as your instruction set, and the human chat message is your prompt, and AI chat message is your output. This is how LangChain interprets it. When you write a code based on that, this is how you will write. Now let's go back to.
I have one question
Yeah.
about
Yes.
system messages. So
Yeah.
basically, when I saw some tutorials, and like when I built my model, uh, what system chat was like a variable defined, which will be common for all the prompts which I'll pass through the large language models.
Yeah.
So Llama 2 has inbuilt system chat message which will apply to all prompts. Is that what it is?
Not really. I mean, yeah, it can be, but so imagine this. Imagine the flexibility. What it's happening here is that uh, so what you said is correct. You can have a like a same system chat for everything, but I want to take it one step forward. So I want to prompt it each time with a new thing. So imagine you have a system chat message, which or system prompt, which essentially is something like, let me share this tab instead. Yeah. So it's essentially that, okay, behave like a behave like a developer in a company or something like that, right? And then every message you pass it to it, you get the same response. That's how it normally works with any of the UIs you have, right? But here we are actually like using LangChain to we are like start these models. We are going to prompt these models, so we can have a system where we can change the system chat message for each of the inputs. So imagine we can do actually like chat where we start with a system message that start. The first message might be uh, act as a helpful developer. Then we send a human text. It gets that. We save that because we can use it for agents. We save that to the memory. Next time when we call the model again with a new when a new call, the model itself doesn't have memory. We are supplying the memory, right? So the model acts as a new, like it doesn't have a system prompt anymore. So we can supply a new prompt. So now with the existing history, we can supply it as a prompt that, okay, act as a senior developer or act as a developer who is proficient in specifically Python or something like that to answer this question. What happens is that instead of like going through a very large broad spectrum, it guides the model to answer on a very specific data set. Or we can pass it very specifically that answer based on only the context given in the chat. So we can pass it as a system prompt, and it guides the model towards more outputs towards the content of the chat. So that's the difference when you use any like when you assign it universally versus when you again and again call it through something like LangChain, or you can do it manually as well. But each time you can pass a different system prompt and pass the whole context and get a very different result than the previous one.
So the system chat messages will be dynamic according to the prompts and
According to how you want it to be.
how we want it. And LangChain has some inbuilt functionality which will help us to which will help LLMs to uh, better give us answers.
Yeah. So okay, I'll show it there. So l- using LangChain, we can just assign the system chat message. So these are like Python calls, right? So we can just build a list with a certain number of system chat messages, and for example, just like key value store, something like that. And you can like code it such way that, okay, if the questions are WH questions, then act as a assistant. If the questions are have any word code in it, act as a developer. If the question has any kind of explain word in it or something like that, then act as something else. So this is just a very like basic example I'm giving, but imagine you can just write a code to dynamically adjust your system chat message, and that changes how your application behaves, right?
Yeah, got it. Thank you.
Yeah.
Yeah.
So these are the like interesting like things you can play with it, which are normally like you will have to like code a lot to build. So these are the like easy things that LangChain or Llama Index both will provide you.
Got it.
Any other question? Any other
So
doubts?
is that like metadata that so that every time LangChain is the one that's holding all of this information and it gives that as an input to your model so that your user doesn't end up have to keep saying the same thing again and again?
Kind of. So so our user technically doesn't know the system prompt at all, right? So the system prompt is essentially hidden from the user. So just give me a moment. I am trying to show you a demo, and I'm trying to get my API key. Yeah. So the system user, so the user doesn't see the system prompt at all. So we are prompting the like output dynamically based on what the input is. That's like one of the use cases I'm
Okay,
like talking about now.
got it.
But so the user doesn't have to give that, and also we don't have to like hard code it. We can dynamically choose it, something like that.
Thank you.
Okay. Let me actually show a very different example. So I'm sharing a different tab. So this is not using LangChain, but since we are talking a lot about like contexts and like system prompts, I wanted to show this. So this is what this is using, is that it's using Palm, but this is not what I want. Wait, because this doesn't have anything. Just give me a second. Open in collab. This is my API key. Okay, share this tab. Okay, so what I'm doing here is that I'm calling Palm and I am passing it certain very small. I won't say training data, but yeah, you can imagine this as kind of fine tuning. So here, if you see when I'm calling the model, I'm calling the Chat Bison model, which is the only model available to me, and I'm setting a temperature. So what does temperature mean? Anybody has any idea?
Like how much, what's the creativity percentage? Like if it's
Awesome.
closer to one, it will be more creative, and it's if it's closer to zero, it will stick to content.
Okay. So essentially, all these models, like all the LLMs we have till now, are non-deterministic. Exactly. How free the response would be, but think more of a, like, if we think of it a structured way, that means everything we do is non-deterministic. What is non-determinism? Is that we send an input that doesn't guarantee I'll get the same output every time. It will give me different output every time. But as a computer engineer, that's really kind of not really like assuring to me. Most of you probably are software engineers or work with softwares or code. How would you feel if your code doesn't give you a deterministic answer? How would you feel if you write a code and you cannot tell your boss that, okay, this will do this every time? So we're not really always comfortable with that. Temperature, essentially what you guys told, that this makes it creative. Also on the other side, if we ask the temperature to be low, the variation decreases and it will try to stick with one answer. So we introduced a little bit of determinism in our answer. Why that's needed, you'll see. So let's see what is happening. Let me run the model. So what we have here in base64 is information about me. I'm just passing it as base64 because that's easy. I can actually show you what it is. Copy. Okay, if I copy it, this is the example part. And okay, let me first run it. So after I run it, I did not pass anything on context and example. Then right now it's not asking anything, so I'm gonna ask. Okay. It gives me kind of like a bio, which I'll show. This is not part of the training dataset. So it kind of tried to like summarize what I work on. Let's see, can it answer more creative questions like, uh, okay, now see the interesting thing. Just before till that, how was my question? So the first question was asking something about me, but specifically asking about me with my name, and it was able to answer that. The next question, what I asked is, if I do Control Z, what does he work on? So I never gave a context on what, like, who is that he or anything, and it was able to answer based on the information it had. But then when I asked, can he drive a car? Ideally, it should not be able to answer it, and it should just tell me that, okay, he cannot drive, or I don't have that information. Instead, look at the answer. I'm large language model also, etc., etc., etc. I am not able to drive a car. So what's going on here? So even though we have trained it on, we have like guided it towards a very specific response using the schema, using the system prompts, it's not always easy to change the weight of its own, like what its own training and data set is. So even though we are supplying it the context, we are again and again supplying it the whole conversation, if the response it's coming from its own weight over goes beyond what we have, it will still answer that. So no, this is not actually hallucination. Hallucination would be something like, I haven't tried it, so let me try if it does this. Ideally, it should not, like, it should just tell it doesn't know it's a large language model or something like that. But see what it produced. So what's happening here? Anybody has any idea? So what we just did is that it went through my CV, it found certain competitions I have participated in, it found certain hackathons I have participated in, it found certain other things or talks I have given, found those instances, saw the similarity. So achievements are generally associated with what? Competitions, something you win, or something like that. These are associations which are already inside the large language models. I did not do any training. I did not do anything with that. What it's doing is that it's going there at trying to see my CV, trying to associate that. It's taking the question, splitting it, each of those parts. So tell me about his achievements in beer bike. It's assuming I know what I'm talking about, and achievements is associated with beer bike. That means anything that in its mind associated with achievement in my CV should be beer bike. So it's hallucinating about that. So that's enough fun for today. Let's go back to our original LangChain. Oh, did I stop share completely? Wait. Let's go back to our original LangChain example. So anybody has any comments or any questions till now? Okay, we'll move forward. So we saw some of the things LangChain can do and how does it look like when you want to implement it. So imagine I'm just installing a couple of libraries here. So let's go through it, like what we are doing, like what we are installing here. So we are installing LangChain. So this is in PyPy. If you have worked in Python, so you just do a pip install and it should install it. We're installing OpenAI so that we can play with the ChatGPT's API and certain other things. Cohere, if we want to use Cohere's API, which I won't, I don't have access to that anymore. We are using Hugging Face Hub because I want you to show also. I want to show you also the how you like play with the open source APIs, open source like models. Some of these we want to use to kind of just do kind of like just show that okay, what other things you can do. So for example, the ChromaDB is a vector database and that you can use to kind of like store and work on the data. Vector database is a very interesting concept which we won't be discussing today in much detail, but if you have any questions, just feel free to interrupt me and ask, and I'll be happy to kind of just give a small description on it. The transformers and tick token, we are gonna use it later. So let's go forward and okay. Next, I'm gonna install the transformers library, which we will need for Hugging Face, and then just import these. So here, when I'm importing, you will see these three we just talked about, right? So we just talked about the three kind of chat messages we needed from LangChain. So these are those three. So from LangChain schema, we are importing AI message, human message, and system message. If you remember, when I was in the like LangChain's documentation page, these are the exact three messages that were available to us. Once that is satisfied, I need to run the API, which since we are recording, I'm not showing. So I'm just running it. So these are all of the like LLMs you can integrate with, and this like this list is old. There is much more support with LangChain right now. Let me just go to LangChain's page quickly and show you how like what are the models it supports. So I'm pretty sure the available models were here. I can always Google out. Where is the list of models?
Is it on the integrations page? I think.
Yeah, I forgot. You said integrations?
There, I saw a link up there on this page. If you just scroll up on the center page.
This one?
No. If you head back, just hit the back button twice.
In
the call out on the info.
I was pretty sure I saw it I mean, it had a list. Interesting. But I can find the list. Like they had a huge list of models that were available, which I don't see anymore. Anyway, let's go back to our tab. So for today, we are not gonna like go through all of these, but these all our models are supported and much more.
So I sent a link in the chat.
Yeah, the providers this one
Might
has.
be what we are looking for. I'm not sure. But they
No,
have a
not
huge list on the
this.
left side.
Yeah, no, not this providers. There was a huge list of all the LLMs it supported. Okay, okay, I got it. I got it. But thanks a lot, An, because I found it because you shared that link. Okay, so this is what I was looking for. So this will be very useful to you. I'll share the link in chat because this is very useful to. Oh, Mario, thanks for sharing that. Yeah, that's the link. So when you build certain things, you should kind of like go back and look at it so that you know which features are supported for your model, which is not. So if you just scroll through the thing, you will see a lot of things are supported for a lot of things. So today we are mostly gonna use gonna see that Google Palm, and there should be something called. So we are of course gonna use the OpenAI one, and there is a Vertex AI. So Vertex AI and Google Palm at the back end hits the same exact model, the same exact LLM, but how they work or how you interact with it is different because Vertex AI is part of Google Cloud platform. So it has more security features, it has more training platforms, and a lot of other things available, good things available, and it's very well supported as you can see in LangChain. Google Palm is kind of for experimentation purposes, a pretty much rate limited model available through MakerSuite, very similar to how OpenAI has two things. So one, you can access the OpenAI model, which we'll see. The API you can get through OpenAI, it's a paid API, but the same model you can access through Azure as well. And I'm pretty sure they support Azure. So yeah, Azure OpenAI, also you hit the same models, but a lot of other models as well. So this page is good to kind of like have a reference so that you know what models it's working for. Okay, so coming back to our example, what we did till now, we just installed a bunch of things. We imported LangChain, and we also imported the API keys. Now, if I want to run it, first I'm just initializing ChatGPT and GPT-3. So anybody has idea? Both are ChatGPT essentially, right? So why these two are different? Like what did I just do?
Is one
So
a chat model and the other is just a text generation model?
not, not really, but the thing is that what we see as ChatGPT is not really GPT-3. That's GPT 3.5. So Chat GPT here, when we define as Chat GPT and Chat OpenAI, and of course for Chat, so this is going to the model GPT 3.5 Turbo, and the GPT 3 model, when we are referencing it, the text DaVinci 003, and also not using a Chat OpenAI, just as a quick Q&A. So this is reverting to the GPT 3 model, and Bloom is we can use anything other than Bloom as well, but this is just I wanted to show how you can use any Hugging Face model. So you literally just pass the model ID here and what task you wanted to use. We also pass the temperature and the maximum length, which is right now for Bloom. For this one is supported 64, and we run it. Once we are done with it, we can actually play with it. So I'm just defining a tasks like how to be happy, or actually, okay, let's do something interesting. Okay, I used all the RAM. Okay, so I need to run again. Let's see if we still run out of RAM again. That's because of Bloom. If we still run out, then I'll have to keep Bloom out. But it does not always happen. So the question I changed how to do a presentation in GDG, it might not have context of what a GDG is unless I give it like what is Google Developer Group. Even then, it will still give me an answer because it will try to create association based on the sentence that okay, presentation in something, and it will just try to hallucinate for GDG what can be a presentation. For our purposes, that is not really going to be a hallucination. That is going to be an answer. So let's see what it does. Okay, we did not run out of memory this time, hopefully. So it did find out GDG is a Google Developer Group. So this is ChatGPT's answer. So it gave us like follow this step 1, 2, 3. We pass it to only GPT-3. It gives me an answer. If we pass it to Bloom, so one of the downsides of doing I will also share the like IPI directly the IPIMB file with An so that I can share An can share with everybody else. I am intentionally not sharing the link because I cannot do that unless I create a new copy. Otherwise, the API keys will be like it will stay there. So the IPIMB file I'm gonna send, it will have placeholders where your API key should be, and you can just put your API key and you should be able to run it. So see, for Bloom, this is the presentation like this is the answer I got. How to do a presentation? How to? So it just kept on repeating the same thing, and it's stopped in the answer. So we can see already that okay, for a smaller model, how is it not that good? But till now we have done nothing with LangChain apart from just importing the library. So let's see if we want to do anything with a like external file, what we should do. So I'm gonna just load it. So I have a state of union.txt, which is just Googled it out. And I just loaded using a text loader. LangChain has a lot of other loaders available. So we can load PDFs, we can load other libraries and a lot of those. And then we are creating a vector index. Anybody has idea why we are creating a vector index or what is a vector index? But before that, let's see what it answers. So we are asked what did the president say about Ketanji Brown Jackson, and this is the answer we got. Let's see if we want to do something else, which is this is more gonna be more creative. Interesting. So can we do something like Did you see a difference between this answer and the one I when I trained it using my own data? So I intentionally am nudging it again and again towards hallucination, and it's still not going. Ideally, if we just like if we don't have guardrails, if you don't specifically prompt it with system messages, it probably will go to somewhere like tell me how awesome the president is, and there is anything that is in state of union which deals with awesomeness or good things, it will probably try to hallucinate based on that. But this is how we can load a text and work on top of that. Now let's talk about memories. So we just talked about like what is a memory, right? If we have to implement it, what can we do? So here, this is how we implement
A
it. So
question.
yeah,
Yeah. So the previous answer, which stated I don't know, is that due to the reason of the temperature setting?
this is let me run it again. So I don't know, right? But let me go back. You see, I set the temperature for Bloom, not for like ChatGPT.
Yeah.
So ChatGPT technically has no, like I didn't set any temperature specifically for that. So it's not based on that. It's based on kind of like how we are nudging it very specifically that load that, and we index we create a vector index based on that, and we query based on just on that index. LangChain inside, when we are using these like components, it has those safeguards that okay, when we are doing that, it will try to keep it only on that conversation. The only difference between this and the one I was doing, where is it? Here is that, see, I did not use LangChain at all. I was directly communicating with the API. I just passed it certain things, and I just asked it a question. I was nudging it. So even here, the temperature is, let me change the temperature. So if I change it to, I forgot if
Close to 1.80.
no, 0 is close to 1 is, I mean, 1.0 is actually going to be very creative. So we set it 0, which should be the lowest. But I don't remember if Palm supports 0 or 0.1, but let's see. So it did support 0. Now, when I like do it in 0, tell me about his achievements. What it did was that it did not add the BR bike part anywhere, but it still gave me the exact same things from which it derived the BR bike. So again and again. So the only change will be if I keep on running it, technically it should give me the exact response again and again. If I ask it the same question. So that's the only change it should have when I change the temperature. But it's not nudging it towards, if it doesn't have an answer, say no, it's not nudging it there.
Makes sense. And going back to the LangChain, when you ran it, is it possible to override that and give the temperature setting also?
Yes, yes. So here, yeah. So here, just how I did it, I can pass the same
Parameters.
things here. So if I just copy this and paste this, it would have the same
Sure.
effect, like their API documentation available. Of course, we should not pass this, and we can, but it restricts it. But
Sure.
ChatGPT G.355 Turbo has what 2.5K, I think, context length, maximum length. So yeah, but we can change the temperature, so and we can guide it towards it. Also, we have not said any specific. Where is it? Yeah, see, we did not set any AI message. Like this is the instruction prompt, right? So it's getting a blank instruction prompt, but we can set it a very specific AI message so that it gets changed.
Makes sense.
So I had a question about the indexing.
Yeah.
We create a loader, we create an index, and then we call this query method on top of it. But what model is it using? We didn't hook anything up. How is it generating from just
So
index?
That's a very like good question. So anyone has any idea what actually vector database does?
No?
Is it like a correlation matrix between
It
image?
is not correlated. Yeah, it's imagine it's a like a distance vector, tokenized, but like what is exactly it does. So let me give you a very super bad, dumbed down, but very like favorite example. Uh, as a human, imagine you have these two. You are given these two information, which is king is a boy, queen is a girl, right? You know that. Now, if I ask you king minus boy, what would be your answer?
It will be
Queen?
queen.
Yeah, but so this is exactly what is happening inside a vector database. So what happens is that when you like whenever you have anything like this, you put all those like so there is a like distance that gets created. So king and boy has a distance between them, queen and girl has a distance between them. So as a human, when we see that king minus girl, that doesn't make any sense to us. But in a vector database, what happens is that you like take one the value of one distance and you subtract it from what is getting subtracted, and now the remaining answer, whoever its nearby elements is, for this one it will be queen, it goes there. So whenever we are loading anything inside text loader and we are doing this, so it does two things. It creates those tokens and it also maps them in the vector database based on how near or far they are.
So does it create, or I guess come up with one vector each for every token in the body of text that we passed in, like the text file, all of the content inside of it? Does it just create one vector each and then um, lets you get back to the location in the corpus? Um,
Not, yeah.
I mean,
Go ahead.
it. I understand how vectorizing tokens or sentences works, but what I don't get is how did it respond with a perfect sentence in English with
Yeah,
good grammar?
that's where the LLM is coming in. So, so what An essentially said is that if we, so imagine, so An, correct me if I'm wrong, if we don't have a LLM and we just do this same thing just using vector database, we will be 90% of the way, right?
Yeah.
Because what vector databases gives us is that it gives us like the nearest body of text. So whenever you are asking like what did the president say about Ketanji Brown Jackson, so it will try to see president say Ketanji Brown Jackson, each of those, and try to find the nearby like texts for all of them. So that's what vector database already will give us without using any LLMs. But they won't be coherent answer. They won't be the exact answer you're getting. What we are doing, what this whole thing does is that you take that, you input that specific part as a context and ask this to the LLM. So the database gives us that exact context and you ask it on top of that. So you get only that portion where it needs to look at and you get the answer. The benefit of that is that you have to work on less number of tokens. Also your cost, eventually the API cost is going to be lower.
Okay, that makes sense. But what LLM is this using under the hood?
This is using chat gpt. Let me show you, like you are getting doubt that okay, it's not like
I mean, we didn't pass any LLM.
yeah, but it's inside. So so I'll tell you, I'll show you an interesting thing where if I just open the same example and if I don't pass anything in ChatGPT and I run it, you will see it will give me an error that it cannot find OpenAI API key. So that part is part of the LangChain code I'm invoking already.
Oh, interesting. Thanks.
So yeah, so now if we want to run it, so yeah, this one. So we are importing OpenAI prompt template, and here we are actually starting to use it. So here, if I send, this is the prompt, right? Can't we do this? I'm trying to like wrap the text so that you can see. Anyway, I thought it's possible. Anyway, so this is our template. So this is the instruction prompt we are sending, and this will be how it keeps the memory, and then we ask it. So here we are assigning the LLM here, and when we run it, so this is our system prompt, this is summary and everything. So this whole thing is our chain. Now it will ask us, like, when I say hi, it is the hi, how can I help you? So if we run this, okay, okay, so it's able to take this, and each time it's getting that, and it's doing that. So now okay, now this probably will be wrong or right, I don't know, but look at this summary. So what's happening here is that we are maintaining the memory, right? So this was the first one, like the human asked me to tell a joke, but no, instead of funny and everything. And current conversation can write a poem for me. I'm sorry, I don't know how to write poem. How many texts did I send you? So here it still has the question. Now, keep in mind that we still have the can you write a poem for me here. And now when I send it again, so what's the last question we have in the memory? How many texts did I send you? Right. So how is it keeping the memory? What's happening is that it's keeping the last two, and anything before that, it's summarizing that and passing it as its memory. So if you look at it, it will like the human asked AI to tell a bad joke. Then no, instead it said a funny story about computer, etc., etc., etc. What the human asked about write a poem, I said it no. Then repeated a funny story about a computer scientist. The human then asked human how many texts it was received. I replied that it had received a total of five texts, right? So this is how the memory is being maintained, and this is what we were talking about, like maintaining a memory. So anybody has any idea or any questions about it, or any shortcomings of this method?
I guess as you keep summarizing, you lose some detail to some extent.
Yeah.
And it might have slight bias towards kind of looking at the last message and the answer and treat it as cost for generating the next answer.
Yeah, so that's I can't talk about the biasness because I have not tested it, but one part where it will become readily evident is that instead of asking it a question answer, imagine you have a user who asks it questions based on code. Now see, so I'm sorry, I don't know how to do that. I'll tell you a funny story about a computer science trying to explain. So what's happening is that I started with this, right? Nowhere it says that it like the conversation cannot be code generation, and we all know that ChatGPT can generate code, right? But what's happening is that since we have a very different conversation going on, different memory going on, and we have prompted it specifically to be on that, and it has a memory of conversation on a very different thing. Now when we try to ask it on very different context, it cannot go, it won't go. So these will be very apparent. So whenever building these chains, whenever we want to keep a memory, we should be a little bit careful about on how we build those memories, how long we want to keep it, and some of these things. Let's go back to our telling a joke. So see, it literally like stuck in that because like that was not a joke, so it cannot answer for a similar joke. So what if we want to build it for very specifically for specific purposes? So let's go back to our documentation. So we looked at how the schema works. Schema had like these chat messages, human chat, AI chat messages. We saw how we can define it, how we can call it, and then we also saw models. The models as LLMs, which LLM models we are going to look for. The chat model, text embedding is the vector database, and then we also saw prompts. So prompts are literally the prompt values. Prompt templates is what we provided it so that it can give us specific answers based on that, and we saw that. Now if we go into chain, so what is a chain? So in very short, it's like end-to-end wrapper, which doesn't tell anything. So a LLM chain is the most common type. It consists of a prompt template, what model we are going to use, and an optional output parser. So we are not going to output parser. So essentially, it will be one end-to-end contained agent, imagine, which will know that if you keep on calling that, you will know that it is going to use this LLM, it is going to use this prompt template, and you can build multiple of this so that each time you can call that and it will get with a different LLM or different in like prompt template, which can be different instruction prompt. How that is useful? Okay, so let's start from here. So if you go for chains, so first we just do the same thing from LangChain. Just import the models, the LLM chain, the chain prompt template, and this is going to be our first prompt template, which is what is a good name for a company that makes product, and this can be anything. And we run the chain with these two names, colorful shocks, and it produced a name, colorful sock company. Now if we give it a second prompt or like a second template, it takes the variable company name which we produced in the first one and write a catchphrase for that company. So we run it. and here we run like a chain both of them. So we have a catchphrase that runs the chain colorful with that input. So this is the temp. This is what it generated. Socket 2M with sock splash. Not very interesting. So let's try with. I like colorful socks. Okay. Oh. Okay. This is much better. So this is how you can actually just mix and match them. So you just add it and you can do anything based on those templates. So you can have multiple templates, you can have more templates, so you can all chain them and come up with very interesting or like examples. So that's what we can do with chains. Anyone has any doubt on chain? Okay, so let's move forward to go back. Yeah, let's go to agents. What is an agent? So agents are multiple things. For example, tool can be like how language models interact with other resources. Agents can be these who drives those decisions, and toolkits are which we can build using chains for very specific tasks. We are not going to go for executors today, but we're going to look at a little bit on all of them. Before we go, however, I want to show you something else, which should be. Just give me a moment. I'm opening up that. Okay, so whenever we say agents, or whenever we are building a model which are kind of like a tool which interacts with each other, remember I told that we can use Palms APIs to kind of use calculators as tools. You can also use each of these to interact with other LLMs doing specific tasks as tool. How? So let's look at this one. Is this the correct one? No. Let's look at this one. Okay. So let me run it. Run it. Oh, wait. So what this part of code will do is that it will create an email. Let's see what we have passed. So we have given it a context, given a topic, write emails in concise and professional manner. And these are some of the examples I gave, which is literally two examples. So one and one. So the first one is a proper email example. The second one is literally kind of like making that shorter, how it looks. So just like two examples. And so I pass it a message like make a reservation, and so it had nothing to do with vacation. I gave it an email example of vacation, and it was able to write me a email for reservation. Now, if I send something like Of course, this is in my mind. So imagine this, you already have, you have done a one shot example that okay, this is an email, this is how you write it, this is an email, this is how you can make it shorter, and use this as a tool for another LLM. One so your agent, like when you are using LangChain, you can use that to kind of interact with this. So one of the tool, so one of the agents can be like a whole concise wrapped this LLM, where you can just ask it very specific, all these prompt templates, everybody is part of that one agent. You just call that agent, send how we write in code, that just pass this any kind of email thing, pass it, and it will generate you an email. And then you have another agent which does something else. For example, that agent tries to do something with that email, or that agent tries to make that email different based on how you are feeling or how the mood is for that employee or something like that. So just an example of how you can use these kind of other tools. Now coming back, let's see if we want to use agents, how we can do that. So I'm running this agent. Here, I'm using something called Setup API. What Setup API does is, anybody has used it before? Okay, so what Setup API essentially does is that it literally gives you an API for search. So if you search, what they do, if I search, it's essentially a Google search. If you want, you can build something like this using Puppeteer or Selenium if you really want to. But I'm just using, because for the example I want to show you, it gives me very nice JSON output, and I was lazy. So you can add it part of any GET request. Curl Ruby, it supports everything, and this is not an add of that. So I'm going back. Oh. Apologies, I keep on closing the thing. So, okay, so let's look at what we are doing. So we are loading the agent, we are initializing an agent, then we are giving it tools. So these tools essentially is this API and the LLM math, which is we are calling in LLM GPT. So which was our GPT-3. And then we just pass it that, okay, what it should do, zero shot React description. And I think I ran it, and then I run it. So it's trying to do two things. One is that who is Leonardo DiCaprio's girlfriend, trying to Google search it, getting the result and distilling it to actual result, and then trying to find the age and raise it to the power of 0.43. Let's see what it does. So it's like I should search and to determine age, action search, action input girlfriend, observation is the actual response. This is the first response from Google search it got, and then this is what it found. Again, it used calculator, and this is the output. So this is the final answer, which we got after the chain is the girlfriend, and current age is 5.2 and something like this, right? If I want to run something like this, I don't know if it will work. So we are not using the second one. So we are not using the LLM math here, only first one. So see, this is the answer we got. Now, if I want to do something more, which is something like, so this is what it found out, which is probably not correct. But so this is how you can mix and mash different calculators, different agents, and this is how it works. And something else we can do is that we can actually directly like there are tools here available which you can use to interact directly with like writing codes and conversing with replics, repositories. So for example, here if we run it, it ran that. This doesn't need to use Python replics, but so it used Python replit to do this input print, and this is the print output, which you should see is not the same as this. So this is one thing to keep in mind. All these LLMs, they are not really good at math for very obvious but interesting reason. Anybody has any idea why the LLMs are bad at math? Any kind of math, more or less.
Because they are fuzzy.
Yeah, but in a very broad context, remember the answer you said, like the description you said at the very beginning of the workshop? What does the LLMs do? They try to find the next possible output, like next possible whatever can be. That's not how math works. So whatever it's trying to calculate, it's trying to imagine, it's trying to paint a calculation. It doesn't know the calculation. It's just trying to predict what can be the second output, which in math is not going to work unless we specify it to use very specific tools whenever we have a calculation based outputs available. So that's one of the like huge problems of using this. So that's kind of like a very big overview of LangChain, and we have not touched a lot of other things. There are a lot of powerful things we can do with agents and toolkits, but this was a very kind of like overall output. So anybody has any other questions on this? Okay, so not this. In that case, let me end with one of the other things I wanted to show. Just give me some time. Okay, so let me run this. And I'm gonna share this, run it. Okay, this is like a example using Palm. What I specifically want you to look at or want to show you is that using so yeah, I just told that these LLMs are not good at math or technically any kind of reasoning, but how we can elevate it or how we can use these tools. So I'll not go with all of these. This is fairly like normal. Just I'm grabbing the API key, I'm generating a text based on prompt like template, and all of those are fine. What I want to show you is using something called calculator. So we can use something called calc as a tag in calculator. This is available in Palm, and it will use a different method to calculate any mathematical uh, things. For example, let me see. So we are providing a calculator prompt that please solve the following problem, and then this should be the prompt. And then this is the system prompt we pass. Use calculator for this step, don't do arithmetic in your hand, etc., something like this. Then when I run it and I run the response and I run the equation, so find the total number of mittens needed. So it created equation for it, the 3 houses, 3 cats. So what was the question? I have 3 houses, each with 3 cats. Each cat owns 4 mittens and a hat. Each mitten was knit from 7 meter of yarn, each hat from 4 meter. How much yarn was needed to make all the items? So this was a question. Like if you're a human, you can follow the thought very easily and you can do that. There is a paper by Google which is called Chain of Thoughts, and there are like a lot of more work on that, which tries to invoke the similar things in LLM, where it tries to think each of those as one step at a time and tries to build on top of that. Using that, it tried to build all these steps, all the steps. So this should be very correct how we should think, and the answer was 288. Now the same thing we are using calculator. So we are stopping it, we are doing the calculate, and then this is the equation we generate. So using this equation, we can feed it back saying that, okay, generate a response based out of that, and it will generate a response which will be more correct than just asking it on its own. So these are kind of how you can use the tools to alleviate some of the problems in these LLM models. So that's mostly what I wanted to show for today. And if you have any questions, feel free to ask me. We still have, I think, 5 more minutes.
It was a great presentation. Thanks for that. From here, what would be the next steps? Ideally, how we need to make ourselves converse in this?
So LangChain has a very good documentation. Almost everything I like showed today, these are available in parts of the like different code repos in GitHub, in all the places. They used to have a even more comprehensive like documentation before, but while going today, it seemed a little bit less. But I am pretty sure that's still available in their GitHub, where they have a lot of resources and materials available. So I would suggest just go through them. People have made a lot of collabs and like examples of that. Just play with them, and you will like just coding. This is not difficult. You will pick that up very easily. I would say from here, from next steps, start learning a little bit about why some of the pain points, why you should use LLM, why you should not use LLM, and what the LangChain, like what it provides and how you can use those to kind of like alleviate some of those problems. I think that will be more important going forward, because these tools are there to make our life easier, to make it easy for us to build these kind of experiences. But we should also be careful about where we should actually use that.
Yeah, rightly said. Thanks for that. And I have another question. In the beginning, you mentioned something about relation to Vertex AI. Do you have that in mind to showcase later sometime in the next session or something?
We can, if An wants, we can.
For sure. I mean, why not? Be sure to, well, that's a good segue to the wrap up. Let me share my screen. Okay. So, yeah, first off, thanks everyone so much for joining, and apologies for postponing it twice. Um, yeah, if you have feedback, love to hear what you thought about this event, how we can make it better the next time, and what kinds of events would you like us to do, what topics you'd like us to cover. Let us know. And yeah, for sure, we will be back with something that you guys would like to, learn more about. So yeah, please do provide feedback here. It's this short link, tiny.cc/GDG feedback. And also drop it in the chat. I've also shared a couple links. One is just LangChain docs, and the other was a YouTube playlist that I found about LangChain. So if you're interested in, kind of deep diving into some aspects of LangChain, you can look into that. There's a lot of stuff that they have been building up, and as Rabimba said, we are just not even scratching the surface yet. So yeah, for sure, let's do more events as and when. Rabimba, if you have time, just let me know and let's set something up.
Awesome. Thanks for having me today.
Yeah. Thank you, Rabimba, and thanks everyone for joining.
Thank you so much.
Thank you very much for doing what you did tonight. I learned a lot, and I'm excited to get started on this.
Yeah, and if you want to keep in touch with me, my first name is it's wait. Hmm. So this is my Twitter, and yeah, this is my email. You can get in touch with me if you have any questions.
Thanks again.
Thank you. See
Thanks
you.
everyone. Bye.
Bye.